Okay, this question asks to test the following series for convergence. So for the first one, I'm going to use limit comparison test. So limit of n goes to infinity, ln of 1 plus 1 over n squared, and the similar format would be 1 over n squared. Okay, and if you plug it in, this is going to be infinity over 0, so it's going to be undefined, so you have to use L'Hopital. So let's do that. So 1 over 1 plus 1 over n squared times the derivative of 1 over n squared. So that's going to be n minus 2, so minus 2n minus 3 over the derivation of 1 over n squared. It would be also negative 2n minus 3, which is cancelled out eventually. So this just becomes 1 over 1 plus 1 over n squared. This is 1 over 1 over n squared plus 1 over n squared. So this is n squared plus 1. N squared over n squared plus 1, which is going to be equal to 1. So this is greater than 0. Oh, so this is greater than 0. So it's going to be either both converging or diverging. But if you look at your first Bn value, which is 1 over n squared, the similar format of ln 1 plus n 1 over n squared, you call it as Bn, and this is our An, our original, if you remember your limit comparison. So Bn is 1 over n squared, and that is converging by p-series test. So this is going to be converging. So the first one is converging. That means A, C, B, and not D. Okay, cool. So second one, so it's n equals 1 to infinity sine of 1 over n. So if you see like a trig function, it's most likely going to be divergent because it's oscillating like from 0 to 2 pi like that. So it's going to be divergent. Okay, so that makes either going to be B, it's not going to be E, either going to be A or B, basically. Okay, let's look at the third one. The third one is square root of n cubed minus n cubed minus 1. Okay, I'm gonna make it into, I don't like the square bracket, so I'm gonna make it into format of multiplying by the conjugate of that. So n cubed plus n cubed minus 1 over n cubed plus n cubed minus 1. So this will just become n cubed minus n cubed minus 1 over n cubed plus n cubed minus 1 square root. There we go. So that will, the above the denominator part will just become 1 over n cubed plus n cubed minus 1. N cubed minus, minus 1. So now we have that. So now I can use what can I use? I can use limit comparison test as well. So if I use the limit comparison test, our An will be 1 over n cubed plus n cubed minus n cubed over 3 minus 1, and then our similar format of Bn will be just 1 over n cubed. Okay, right? Or let me think. Actually, can I just do direct comparison test? I think you can just do the direct comparison test for this one. Yeah, I think so. Right. Yeah, I'm gonna use the direct comparison test. Sorry, I'm not gonna use limit. So, oh, that was too much deleting. Okay, so I'm not gonna do limit comparison test. I can do direct comparison test. That'll be easier. So 1 over n cubed plus n cubed minus 1, I'm gonna compare it with 1 over n cubed. And since that one is added in the denominator, 1 over n cubed is bigger, and 1 over n cubed over square root is same as 1 over n 3 over 2, and then this is by p-series test, it's converging. And since this one is converging, so bigger one converges, then also small one converges. So that tells us that this entire thing converges. So that means the answer for this question is B. Okay, this question asks to represent the cosine of x squared dx as an infinite series form. So cosine of x squared is k equals 0 to infinity, change with x squared, so this is going to be negative 1 to the k, x to the 4k, because x squared times 2k is 4k, so x 4k, 2k factorial, and it's integration, so I'm going to put that everything inside of 0 integrand. So 0 to 1, negative 1 to the k, x to the 4k, or 2k factorial dx. So negative 1 to the k and 2k will be just constant because it's not x. So 0 to 1, x to the 4k plus 1 over 4k plus 1. Okay, 4k plus 1 from 0 to 1. Yeah, my laptop is getting overheated, so it's getting a little slower, which is quite normal. So this is, oh, and then I forgot factorial, I see. So negative 1 to the k, and then 2k factorial, and then 4k plus 1 can come out already, because they are constant. And at this point, you can just stop, because you already see that you already found like the form, but to just, I guess, for the completeness, I'll just prove why that becomes option E. So now you have that, and then now you just have to plug it in the value 1 and 0 in x. So if you plug in 1 to the 4k plus 1, and then minus 0 to the 4k plus 1. 0 to the 4k plus 1 will be just 0. 1 to the 4k plus 1 is just 1, right? Because 1 to infinity is just 1. So negative 1 to the k over 2k factorial 4k plus 1. And you have to have the summation in front, which is k equals 0 to infinity. So the answer for this question is E. Okay, this question has to compute the power series that represent. Okay, this is 1 over 1 plus 2x squared. This is same as the derivation of 1 over negative 1 over 1 plus 2x, right? Because if you derive 1 plus 2x minus 1, this becomes negative 1, negative 1, negative 1, positive 1 plus 2x squared. The only reason that I want to write it in this form, because I know that 1 over 1 minus x, 1 over 1 minus x is same as the x to the n form, so I'm going to make it into that form. So let's write it. This can be written as d over dx negative 1, right? Actually, hold on, there's more to it, right? Because since it's 1 plus 2x, it's 1 over 2 1 plus 2x. That will make it, right? I forgot to consider the chain rule, yes. So if you actually do this part, negative 2, 1 plus 2x minus 1, if you derive it, this becomes 2, 1 plus 2x squared, and then times 2, oh wait, this is 1/2. I'm sorry, negative 1/2. So that canceled out, right? Okay, I'll just rewrite this. Hold on. Okay, so when you have negative 1 over 2 and 1 plus 2x, this becomes negative 1 over 2, 1 plus 2x minus 1, and then if you derive it, this becomes 1 over 2, 1 plus 2x squared times 2. Because of the chain rule, you have to count 1 over 2. So this becomes 1 plus 2x squared, 2x minus 1 plus 2x minus 2, which is same as 1 over 1 plus 2x squared, which is why you have the negative 1 over 2 in front. So then you can take out the constant out, negative 1 over 2, and d over dx of 1 over 1 plus 2x. Okay, now you can use this, you know that 1 over 1 minus x is equal to x to the nth power, so we're going to count that, and this is from n equals 0. For this one, I'm going to put k instead, because we have the k variable. X to the k, this is going to be k equals 0 to infinity. So this can be written as negative 1 over 2 to d over dx, and this is 1 plus 2x, so 1 over 1 plus 2x can be written as k equals 0 to infinity, and it's gonna be, instead of negative x, we replace with 2x, so it's gonna be negative 2x to the n. So this becomes negative 2x to the n, and some people might wonder why it's negative 2x. So this is 1 minus 2x, right? So in here we had a minus sign, which is why it just becomes x to the k power, but this is 1 minus 2x for our x. That's why you replace x with negative 2x. So that becomes negative 2x to the nth power. And this is from, and I've been messing up that it's supposed to be k too. K, and then k equals 0 to infinity. So this is negative 1 over 2, and you have to derive this. So this becomes negative 1 over 2k equals 0 to infinity. And before we do that, I can split that negative 2 to the x to the k power. So this can be separated into negative 2 to the k power, and then x to the k power. So this negative 2 to the k power can be separated even more into negative 1 over 2. K equals 0 to infinity, negative 1 to the k power, times 2 to the k, times x to the k power. Okay, so we have that. And then I can take out the negative 1, or actually, let's think. Think. Right. Negative 2 to the k power, right? Okay. Actually, let's not separate it and just keep it like that. Yeah. You don't have to separate it. So, okay, we have that. So now we just have to derive it with respect to d over dx. Okay, d over dx. So that becomes negative 1 over 2. Negative 2 to the k will just come out because they are constant. And this is x to the k minus 1 over k minus 1 power. Right? So, hold on. Right. Right. Yeah, that is right. Wait. Hold on. I was gonna say. Okay, got it. I was like, wait, what? It doesn't make sense. I was like, what did I do? Okay, so this is negative 1 over 2, right? Negative 1 over 2, if I can write. And then if you derive it, then k becomes 1, because the constant term will be deleted when you find the derivation. So that's why we start with k equals 1 to infinity. And this is negative 2 to the k power, right? Because I was looking at the xk minus 1 over k minus 1, because that's not making any sense. So I was like, what? So this is times k times x k minus 1, right? And then this negative 1 over 2 can be written as 2 to the negative 1, right? And actually this is going to be negative 2 to negative 1 because it's negative sign in front. So negative 2 to the negative 1 power. This is k equals 1 to infinity, negative 2 to the k. And then this is k times x k minus 1. right. So this -2 to the -1 power and -2 to the k power can be grouped together. So this is going to be -2 to the k minus 1. K minus 1. Integrate the summation of k equals 1 to infinity, and then times k times x k minus 1. K minus 1. Okay, which is the same format as the option E. So the answer for this question is option C, not E. So the answer for this question is C. Okay, this question asks to find the first three terms of the Maclaurin series. Okay, let's write it down. Our first one, fx is equal to 1 plus 3x to the -1/3 power. Lovely. Cool. And then, since it's Maclaurin series, it's at point 0. So f of 0 is equal to 1 to the -1/3 power, which is 1. So it starts with 1. Everything starts with 1, so that doesn't help. Lovely. Okay, so f prime of x, let's find that. F prime of x is equal to -1/3, 1 plus 3x to the -4/3 power, and then times 3, because the chain rule. So 3 -1/3 can be reduced to -1, so -1 plus 3x to the -4/3 power. And then we're evaluating at f prime of 0. So this becomes -1 to the -4/3 power, which is just -1. So it's gonna be option E. So we could stop here, but I'm just gonna continue. So it's -1 for the coefficient of the x. That's why this becomes -x. And then the second derivative of x is gonna be 4/3, 1 plus 3x to -7/3 times 3. So that becomes 4, right? Let's see. Yeah, 4, right. And then times 1 plus 3x to the -7/3 power. And then f prime of 0 becomes just 4, right? But if you remember your Maclaurin series or Taylor series, it's always like f of 0, especially for the Maclaurin series, it's f of 0 plus f prime of 0, x over 1 factorial, and then f double prime of 0 over x squared over 2 factorial, right? Which is why in our case we're gonna have not 4 but 2. So 4 over 2 factorial is 2. That's why this becomes 2x squared, which is why the option E is answer as we expected. Okay, this question asks to use the alternate series to find the error. Okay, so error is basically Sn, and then it's basically looking at the Sn plus 1 Sn plus 1 thing, meaning you have to just add 1 power. In our case, it's going to be Sm plus 1 because Sm is that. So, or actually it'll be just Bm plus 1, because when you're looking at the error, you don't care about the sign, like the alternative series sign, like -1 to the k. We don't care about the sign, but we care about the like the form. So Bm will be just 1 over k to the cube power, and Bm plus 1 would be just 1 increase 1 over k plus 1 cube, which has to be less than or equal to 10 to the -3. -3. Yeah, my laptop is overheating, which is why it's getting slower and slower. So this is 10 to the -3, which you can write as 1 over k plus 1 cube is less than or equal to 1 over 10 to the 3 power. So since they both have cube root, you can get rid of it. So this just becomes 1 over k plus 1 is less than or equal to 1 over 10. And cross the multiplication, so k plus 1 is less than or equal, greater than or equal to 10. So k is greater than or equal to 9, which is why the answer for this question is E. Okay, this question asks to find the equation in polar coordinates to represent a part. Okay, so I'm gonna multiply by r on both sides to get rid of the denominator. So it's gonna be 4r cosine of theta plus r sine of theta is equal to 2, right? So, and you recall that x is equal to r cosine of theta and y is equal to r sine of theta. So this can be written as basically 4x plus y is equal to 2. So y is equal to 2 minus 4x. So y equals 2 minus x is something like 2 minus 4x. Still loading apparently. So that's gonna be 2 over 4. So it's looking like this. Okay, so that's why the answer for this question is just a straight line. Okay, this question is asking to find the length of arc of the polar curve. Lovely. And we're given the lengths. If you remember, your length of arc of the polar curve is some kinds of bound, which is in our case is 0 to 1 over 2, and then r squared inside of square root. So it's gonna be r squared plus dr over d theta squared d theta for the length equation. So let's do that. So r is equal to e to the negative 2 theta. So r squared is e to the negative 4 theta. So e to the negative 4 theta, and then dr over d theta is going to be simply negative 2e to negative 2 theta, and then that value squared is going to be 4e to the negative 4 theta. So that becomes plus, if it goes 4e to negative 4 theta d theta. Okay, so that just becomes 0 to 1 over 2 square root of 5e to negative 4 theta d theta. Okay, and basically this can be written as 0 to 1 over 2 square root of 5. You can get rid of the square root, get the e to the negative 4 theta out from the square root. So that just becomes e to the negative 2 theta d theta. Okay, so this becomes square root of 5 e to the negative 2 theta over negative 2, integrating from 0 to 1 over 2. That becomes square root of 5 e to the negative 1 over negative 2 minus square root of 5 e0 over negative 2. This becomes positive plus 5 over 2. So this is negative 5 over 2 e negative square root, of 5 over 2e plus square root of 5 over 2. Okay, so this is right, so this you can group that by 2e, so that becomes 2e square root of 5e minus square root of 5, right? So that can be written as 2e on the bottom square root of 5 and e minus 1, which is same as option E. So the answer for this question is E. Okay, this question asks to find the sum of that. Okay, so 3 plus 2n over 2 to the 2n which can be written as 3 over 2 to the 3 over 2 to the 2n, n equals 1 to infinity, plus 2 to the n over 2 to the 2n, n equals 1 to infinity. So this is same as n equals 1 to infinity, 3 times 1 over 2 to the 2n, and then the second part can be reducing to n equals 1 to infinity, 1 over 2 to the n, because they both have n power. So we have that, and then you can take out the 3 in front because 3 is the constant. 3 is n equals 1 to infinity, 1 over 2 to the 2 to the nth power, plus n equals 1 to infinity, 1 over 2 to the nth power. So this is basically the geometric sum. Geometric 3 sum, yep. So this is 3, n equals 1 to infinity, 1 over 4 to the nth power, plus n equals 1 to infinity, 1 over 2 to the nth power. So if you remember the geometry series infinite sum, it says infinity is equal to a over 1 minus r. A first term, if I can write, r is rate or ratio. Yeah, let's change it to ratio. Okay, so in our case the ratio is 1 over 4, and the important part that you have to remember for this thing is ratio of r has to be less than or equal to 1 for the absolute value, which both case is less than or equal to 1 for the absolute value, which is why you can apply this equation. So let's do that. Let's do this one first. So I'm going to put this as S1. So S1 is equal to, equal to A, which is the first term, which is 1 over 4, over 1 minus the rate is also 1 over 4. 1 minus 1 over 4. This becomes 1 over 4 over 3 over 4, which becomes 1 over 3 for that part, but also you have to multiply 3 times 1 over 3, and then plus the second part. Let's do the second part. S2, the first term is n equals 1, so 1 over 2, and then 1 minus the ratio is also 1 over 2, so that becomes 1 over 2. So that becomes just 1, so plus 1. So this just becomes 1 plus 1, which is 2. So the answer for this question is E. This question asks, for which of the following series the ratio test is inconclusive? So okay, let's use the ratio test because it says so. So 7 to the n plus 1 over n plus 1 factorial, and the limit of n goes to infinity, and then divided by the original, multiplied by the reciprocal. So 7n on the bottom, and then it's going to be n factorial. Okay, so this can be separated into 7n times 7 over n plus 1 times n factorial times n factorial over 7 to the n power. 7 to the n cancelled out, n factorial cancelled out, so all we left is 7 over n plus 1, which if the limit of n goes to infinity, this is just going to be 0, so which is less than 1. So it is converging. So it's not inconclusive. So it's not A, it's not D. Okay, let's try number 2. So this is n equals 1 to infinity, 1 over n squared, if I can write. So limit of n goes to infinity, 1 over 1 over n plus 1 squared, and then divided by 1 over n squared, multiplied by the reciprocal, so this is n squared over 1, so this becomes, so the power of n plus 1 squared and n squared is both 2, so this becomes just 1 if the n goes to infinity, which ratio test said if the division of this thing becomes 1, then it is inconclusive, so 2 is inconclusive, and I circled it somehow. I called it, I guess. So B and E, not C then. Okay, not B and E, but yet those are the options that we can, like, I guess those are the only options that we are left with. And then the third one, let's try finding the third one. So this is n goes to 1 to infinity, and we're going to do limit of n goes to infinity of ln of n plus 1 over n plus 1 divided by the original, which is multiplied by the reciprocal, so this is ln of n over n. N and n plus 1 have the same power, so if the limit of n goes to infinity, this just becomes 1. ln n plus 1 and ln n also have the same power, so if n goes to infinity, this is also just going to be 1, which is why this is going to be inconclusive as well. So the answer for this question is E. Okay, this question asks to find the area. Okay, so finding the area of the polar curves, let's draw it first. R equals theta, it's looking like this. If it's like from 0 to pi over 2 only. And then R equals 2 theta, so this is looking like this. Okay. And yeah, R equals 2 theta right there. So when you're finding the area of in between those regions, R equals 2 theta and R equals theta, so this is going to be this region, right? Which is basically area, using the area function of the polar curve. Area is equal to 1 over 2 and 0 to pi over 2, and you have to square the r value, so the bigger radius is 4 theta squared, and then the smaller radius squared would be theta squared, and integrating from 0 to pi over 2 d theta, so this is just 1 over 2, 0 to pi over 2, 3 theta squared d theta, so this becomes theta cubed, 1 over 2, theta cubed, 1 over 2, and this is pi over 2 to 0. So this is 1 over 2 times pi over 2 cube, which is pi cube over 16. And if you do the 0, if you plug in 0, that just becomes 0, so I didn't calculate it. So this is pi cube over 16. So the answer for this question is C. Okay, this question asks which of the following is true, and the point is 1 comma square root of 3, not negative. So R can be found by square root of x squared plus y squared. In our case, x is 1, so it is 1 squared plus y squared is square root of 3 squared, which is square root of 1 plus 3, which is square root of 4, which is 2. Great, everything has 2. Lovely. Okay, theta is tangent inverse. If I can write, laptop, this is the last question. Okay, tangent inverse of y over x. Loading slow. Okay, so tangent inverse of point square root of 3 over 1, which is same as pi over 3. So that means our option 1 works. Okay, so not B or C. Okay, and let's look at the other options. So the point is at 1 comma square root of 3, so that means it's in the first quadrant. And the second option, 2 comma negative 5 pi over 3, negative 5 pi over 3, negative 5, I can write, or no, okay, fine, negative 5 pi over 3, loading, okay, negative 5 pi over 3 is same as negative 2 pi plus pi over 3, right? Because negative 2 pi is negative 6 pi over 3. And if you add plus pi over 3, that becomes negative 5 pi over 3, right? I will express it into negative 2 pi plus pi over 3 just because I want to like move from here. So this is going to be negative, this is going to be negative 3 pi over 2, and then negative 2 pi will be here, but it's pi plus pi over 3 that makes it in the same quadrant and the same angle as pi over 3. So that means 1 and 2 is right. So that means A is not right, so it's going to be either D or E. So let's look at the second one. 2 comma 4 pi over 3. So 4 pi over 3 is same as pi over 3 plus pi, which is in the third quadrant here, which is not in the same quadrant, and the point has to be in the first quadrant, so 3 is not right. So that means option D is the right answer. So we're done.